Alright, we are at the end of the first chapter. 1.7. Find perimeter, circumference, and area of shapes. So we're going to go through the formulas before we start. Perimeter, as you know, is the area around a shape. In a circle, that's called the circumference. So the circumference is the distance around a shape. The area is the distance of the surface covered by a figure. So that's the difference between this. Perimeter and circumference are measured in units of length, such as meters, m, and feet. Area is measured in square units because it has two dimensions. So make sure that when you use the units, they're squared, like meter squared, feet squared. Makes a big difference, right or wrong, depending on the unit. So let's look at some of the formulas that we're going to use. Okay, so formula for perimeter, area, and circumference. So looking at a square, some of this should be familiar, if not all of them, or bring back your memories real quick. A square, perimeter, the sides are all the same, so you can just add all four sides or call 4 times s. Same thing. The area is one side times one side, so it's side squared. Then a rectangle, the perimeter is they have two lengths the same and two widths the same. Area is length times width. A triangle, if you want the perimeter, you just add A, B, and C up, all the outside lengths. If you want the area of a triangle, it's half the base times the height. So you want to make sure you have all this written down. You can use this on tests. You can always use your formulas. Make sure that you have them written down so that you can access them. Circle. The diameter is from one end of the circle to the other, the total diameter here. And the radius is always half of the diameter. So the two formulas that you can get the circumference by is pi, which approximately is 3.142, but it does go on forever. Pi times the diameter. So if the diameter is 10 times pi would be the circumference. Or the other formula should make sense. Instead of pi times d, we have 2 pi r squared, because we know that the two radiuses make up the diameter. So that's where you get the 2 times the radius times the pi. And area equals pi r squared. Alright, so we're going to start with the first, where it's a perimeter. Wants us to find the perimeter of this basketball court, a perimeter, and the area. So we see the units are in feet. So it doesn't matter what we start with. Let's start with the perimeter. So the formula for perimeter is 2 times the length plus 2 times the width. So obviously the length is always the longest. That's going to be 84, and the width is going to be 50. So instead of saying 50 and 50, 84 and 84, this is a shortcut. 2 times 84 plus 2 times 50. So you're going to work that out. That's going to be 100. And real quick on my calculator, 2 times 84 is 168. Just to make it quicker. So 168 plus 100 is 268. And I'm going to put the units, and it is one dimension. So you do not need squared. So that means the perimeter of the rectangle is 268 feet. Now if we want the area is length times width. So 50 times 84, so those are the two dimensions we're multiplying by. So we're going to end up with feet squared. So if I take 50 here times 84, we end up with 4,200 feet squared. So that's the difference between the area and the perimeter. So we're going to move on to the next shape. Let me just erase this. Let's see what the next shape is. Alright, so find the circumference and area of a circle. Alright, so let's go ahead and do it here. Trying to fit this, make it up so we can see it both. Okay, so all they've told us is a circle and this, the diameter is 9 centimeters. Alright, so we know that we have to do the two formulas. So circumference is pi times d, or 2 pi r. And the area is pi times r squared. Since the area needs a radius, we might as well use the formula for the radius for the circumference. So the diameter is 9 centimeters. So half of 9 centimeters is 4.5. 9 over 2, or we would say 4.5. Alright, so we're going to get the circumference first, which is like the perimeter. So we're going to say 2 times pi times 4.5, and it's always going to be approximation. So I'm going to go ahead and just use my calculator. I'm not shortening it. 2 times 4.5 times pi. It's approximately, the circumference is approximately 28.27 or 28.3. However, tenth or 100th, they're going to tell you. If not, just go 1 or 2 places after. I'm just going to do 2, and that's just going to be centimeters because that's one dimensional. That's the circumference around the circle. Now the area is 2 dimensions, so pi times the radius 4.5 squared. So normally the area, not always, but most of the time the area is always bigger than the circumference, especially as the circle gets bigger, times pi. So here we go. The area is 63.6 centimeters squared. So those, always box in your answers and make sure you show your work so you can see all your steps, how you got the radius. You're just plugging into a formula, so that's pretty straightforward. Alright, the next one, we're going to go ahead and use this. I'm going to go ahead and hone in because it's easy just to look at the example and follow the example, especially when it's like graphing, because I don't have the nice graphing that they have in the book. So it says a triangle QRS has vertices Q here is at 1, 2, R, the vertices here, is at 4, 6, and S is at 5, 2. So they give you A, B, and C here. So what is the approximate perimeter? So they want to know the perimeter, so I'm covering that up. See the 8 units, 8.3, 13.1, or 25.4. So we need, and I'm just going to highlight this in red, we need to find the distance from here to here. We need to find the distance from here to here. And then we need to find the distance from Q to S. Okay? So one of them I can find straight away without using a distance formula. If it's straight horizontal or vertical, you can count. So I can count from here. 1, 2, 3, 4. So I know that QS, this distance is 4. So that should be pretty straightforward. You can tell that that's 4 units, and they're not telling us what the units are, they're just saying units. So we've gotten this one right here, it's 4. Okay, but from between here and here, and R and S, we have to use the distance formula. So the distance between QR, so the point is, ordered pair is 1, 2, and 4, 6. So we're going to have to use a distance formula. So they go ahead and use it. So second x minus first x. So 4 minus 1. Put it under the square root squared. Plus the y now, 6 minus 2 squared. So 4 minus 1 is going to be 3 squared, which is 9. Plus 6 minus 2 is 4. 4 squared is 16. 9 plus 16 equals the square root of 25. Now the square root of 25 is a perfect square. It's 5 units. Doesn't normally happen like this, that you come out to a nice integer, but here you did. So far this is 4, this is 5, so you have a total of 9. So that means you can get rid of A and B. It can't be those. So that means you're down to a 50-50. Alright, so the last, remember you always do it alphabetically, R comes before S. This length, we're again going to do the distance in the x's and the distance in the y. So they went distance in the second x minus the first x. So 5 minus 4 squared plus, now the distance in the y is 2 minus 6 squared. So 5 minus 4 squared is 1. I'm just going to put that. Plus 2 minus 6 is negative 4, but negative 4 squared is 16. Then 16 plus 1 gives me the square root of 17. And the square root of 17 is 4.1. So when we add 9 plus 4.1, the only option is C. So then you're going to go ahead and mark C. So when you have this, you need to have graphing paper and look at it, and you need to use a distance formula. So understand, if I have a distance going straight up and down like this, I can count that. So this would be 1, 2, 3, 4, I can count that. But when it doesn't go straight vertically or horizontally I can count. Whenever it has a line that slopes, then you have to use the distance formula. You can't count anymore. So there you go. That's pretty straightforward. You just had to use a distance formula on 2 lengths, and it's not difficult to use. Just be careful. And there it's clearly 13.1. Alright, we're going to look at an last example. Let me go ahead and I'm going to draw it and follow what it says. We've got a triangle here, okay, and here, so 90 degree. This is H they have here, and then the length along here is 28 m. So there is your triangle. I'm going to put it up a little bit. Okay, so we have a little bit more room. They're right in the middle. So it says the base of the triangle is 28 meters. Alright, we can see that. Its area is 308 square meters. So I'll go ahead and write that. There, we can fit that all in. Okay, find the height of the triangle. So first let's write the formula for finding the area of a triangle. So area equals 1/2 base times height. So I have 3 variables, area, base, and height. If you want to solve, you have to at least know 2. So you look at what you're given. They want height, that's the unknown, so they're not going to give, they have to give us base and area, and they sure do. The area is 308, so just plug it in. 308 equals 1/2 times the base is 28 times the height. That's what we're looking for. Very straightforward. 308 equals, what's half of 28? That's the way you can look at it. Or 28 divided by 2. You should see that's 14 times h. Then I'm going to divide 14 into 308, and as you're working, you're showing all your work. So the height is going to be 22. And will it be meters or meter square? Hopefully you know by now that's just going to be meters because it's just one dimensional. So there, that's how you plug into the formula. So you were given the area, you were given the base, but they just wanted the height. So plug everything in. As you can see, as I told you before, a lot of it comes down to your algebra skills and remembering how to do that. So you're just going to be solving for the different shapes, so make sure you've got your formulas, look at what they're asking. Don't forget your units. Are they meters? Are they meters squared? And you should be fine. Okay guys, that's it for chapter 1.